So reaction rate, okay? When we're talking about reaction rate, we're talking about the speed with which products are formed, right? Let's say you have to look at reaction rate as the time, for example, that your mom takes to cook food. So when she mixes all the ingredients to prepare that delicious meal, how long does it take for the food to get ready? So just think of it that way. It's the same way with chemicals. When we mix chemicals, it takes a certain amount of time for all the reactants to be converted into product. And so that time it takes for reactants to be converted to product is what we call the speed or the reaction rate. And so it's the speed with which products form from reactants. Okay. And so what are some of the factors that affect the speed of reaction or the reaction rate? These factors are concentration. What is the concentration of the reactants? What is the temperature at which the reaction is taking place? And now, are you using a catalyst? Again, we are going to see what all of these are as we unfold this section. Okay. So reactant molecules have to make physical contact with each other in order to transform into products. So what that means is that you have to, like, if you are trying to make food, your ingredients have to touch one another. They have to touch one another. For example, the water has to be in contact with the ingredients, right? And the seasonings and the rice and the tomatoes, all of that have to be touching one another in order for you to hope that at the end you will get a final product, which is the food you're trying to cook. Because you can't be having the tomatoes in Moreno Valley and you have the salt in Paris and you think that they are just going to react at a distance. That's what it means. They have to come into physical contact for the products to be formed. Okay, so when we're talking about the reaction rate, we say it's the speed with which products form from the reactant. And so when we're talking about concentration, I want you to see how what we mean by concentration. So look at these two boxes right here. So this is an example of a concentrated medium, because when we're talking about concentration, it means that you have more molecules in a specific space, right? This is a less concentrated environment because here, in the same amount of space, you only have four molecules. But in the same amount of space here, how many molecules do you have? You have about 10 molecules. So you have many more molecules in the same amount of space compared to this one. So the term that we are going to use in science to describe these two scenarios is that this is a more concentrated environment compared to this one. So just imagine that you guys are in a classroom and you are just four of you, right? We will say you guys are less concentrated than than a similar classroom that has 36 students. So if you guys are 36 in a classroom, we will be talking about you guys being more concentrated than being in a classroom with four students. Okay. So the more concentrated the sample of nitrogen and oxygen, the greater the likelihood that the nitrogen and the oxygen molecules will touch, they will collide. So remember that when we're talking about concentration, if you guys are closer to one another, or if the molecules are so many in a space, there is a higher chance that they will hit against one another. And it is the hitting against one another that leads to a reaction. So if you guys are far away from each other, or if the molecules are far away from each other, it reduces the chances that they will hit one another. Okay. And so a reaction that takes place in a more concentrated medium is has a higher chance of taking place faster than one with a less concentrated medium. All right. So now let's look at the temperature. So temperature, what it does is that when you increase the temperature, you are increasing what? The average kinetic energy of the molecules. You are increasing the energy that this molecule will have to move around faster. So when you're increasing the temperature, you are increasing the likelihood that these molecules will hit against one another. Why? Because you're supplying these molecules with energy. And so when you're supplying these molecules with energy, they will start walking around faster, right? And so since they are walking around in the container, they will increase the chance that they will meet as they're walking around randomly. Okay. And so increasing the temperature will increase the likelihood that they will collide and therefore react. So, what I just want you guys to understand here is that the reaction rate is going to increase with temperature. Okay. And on the other one here, reaction rate will increase with concentration. So when you're increasing the concentration, you're going to that is going to lead to an increased reaction rate. When you're increasing the temperature, this is going to lead to what? An increase in reaction rate and vice versa. So if you decrease the concentration, it will lead to a decreased reaction rate. If you decrease the temperature, it will lead to what? A decreased reaction rate. What does it even mean for a reaction rate to be decreased? Reaction rate simply means that if you are trying to cook, an increased reaction rate will simply mean that, okay, the time it is going to take for the food to get ready is going to be 5 minutes. Now, a decreased reaction rate will mean that this time is now increased to what? 1 hour. So you will have to wait 1 hour for that reaction to take place. Okay. But if the reaction rate increases, let's say instead of having 5 minutes, in 2 minutes, your food is ready. That is an example of increased reaction rate. Okay. And now, another way we could increase the reaction rate is using what we call a catalyst. Okay. So I'm not going to go so deep into this, but a catalyst is a substance that helps the products to convert very fast. I mean, that helps the reactants to convert rapidly into product without participating in the reaction. So the catalysts, they are not consumed in the reaction. They don't participate. They only come and help. Okay. They just come and help the reactants to convert into products without themselves participating in the reaction. Okay. And so they do it using a mechanism which is reducing what we call the activation energy. And I'm not going to go into that at this point until we get into a chemistry class. Okay. So again, what the catalyst does is they reduce the activation energy. So I'm not going to go into that. So let's look at this question. You carefully examine the following reaction sequence of the catalytic formation of ozone from molecular oxygen. Which chemical is behaving as a catalyst? Okay, so the only thing you need to look at is you need to look at the molecule that is not consumed in the reaction. So just find out the molecule that you have at the beginning and that you have at the end again. Okay, so there's certainly a molecule that you have that is not going to be consumed. So you have it at the beginning and you will have it again at the end. Okay, so you just got to be careful at looking at which one. Okay, you just got to look at which one is not going to be consumed. Okay, and so if you look at it, you see this molecule here is at the beginning and is also here as a product. Okay. You have it here as a reactant, you also have it here again as a product. So this is going to be the catalyst because a catalyst is just there to help the reactant molecules to convert into product, but you will not have it consumed. Okay. So now let's talk about the concept of exothermic reaction. Okay, a chemical reaction that results in the net production of energy. So if you mix chemicals together and energy is produced, that is called an exothermic reaction. Now, on the other hand, you can have what we call an endothermic reaction. An endothermic reaction is a type of reaction that consumes energy. Why exothermic reaction is a reaction that produces energy. So you need to see that difference. Exothermic produces energy, endothermic releases energy. I mean, endothermic consumes energy, while exothermic releases energy. Okay. So this is what we call the bond energy terms. I just want you to look and pay attention to this table, and I'll just explain it briefly. So if you look at a hydrogen molecule, we write the hydrogen molecule as H2, right? And what that two means is that in one molecule of oxygen, you have two atoms that are linked. And so the force that is holding the oxygen molecule is what we call a bond. Okay. That is called a bond. And this value you see here is the energy that is going to be used to break this bond. So if you want to break this bond, you will have to supply 436 kilojoules per mole of hydrogen. So if you want to break the bond between hydrogen molecules, then be ready to supply this amount of energy to break the bonds. Okay. So that is just the general knowledge I want you to have at this point. So all these bonds that you see, this is the amount of energy that you need to break 1 mole of those bonds. Okay. So it says use the bond energy below to determine whether the reaction is exothermic or endothermic. Okay. Use the bond energy below. So we're not going to pay attention so much into the calculations. Okay. We're not going to focus so much on these calculations. I just want you guys to understand those concepts of exothermic and endothermic and how this concept can be used to uh, for you to understand that you need energy to break bonds, and when bonds are formed, they release energy. Okay. All right. So the last part we're going to be looking here is entropy. Okay. Chemical reactions are driven by entropy. So what is entropy? It is the natural tendency of energy to disperse from where it is concentrated to where it is dilute. Okay. Example, you have a hot pan, irradiates heat. Okay, the hot pan, that is where energy is concentrated. But when you stand beside a hot pan, what do you feel? You feel some of that heat being radiated towards you. Okay, so that's what entropy is all about. When you're burning gasoline, what happens? The gasoline combusts into smaller molecules, and then when you're crushing or maybe marbles bouncing off the floor, it comes to the top. Okay. So the term entropy is used to describe the degree to which energy has become dispersed. So energy has a tendency to move from where it is concentrated to where it is less concentrated. Okay. So reactions that result in an increase in entropy tend to occur on their own. Okay. What type of chemical reaction leads to a greater dispersion of energy? Again, we said it's exothermic. Exothermic do what? They release energy. Exothermic reaction actually do release energy. Okay. All right. Exothermic reactions tend to be self-sustaining because they lead to large increase in entropy. Okay. Exothermic reaction tend to require continual input of energy. Endothermic reaction, they tend to require continual input of energy. Why? Which means that for endothermic reactions to take place, you need to keep supplying the reaction with energy. And a very typical example is what? Photosynthesis. So if you've done that in science or in biology, photosynthesis is a process whereby plants use sunlight to trap. They use the chlorophyll in their leaves to trap sunlight and use it to convert carbon dioxide and water into what? Into carbohydrates or sugar. Right. This comes to the end of this section.